Wildcats. This is Unit 0 focus question number 1, practice problems. So just wanted to do a few examples so as you work through yours, you can kind of get an idea of what it might look like to solve some of these. So it says here, a student measures the distance of a ball that rolls to be a student measures the distance a ball rolls to be 3.47 feet. What is the distance in standard metric units? So how far did the ball roll in standard metric unit? So we can't be done until we get to the standard metric unit of length. So do we remember what that is? If you do, it would be meters. And so, right, length, distance. And so they tell us that it is 3.4, they measure 3.47 feet. We need to get to meters. So we're done when our only unit left is meters. So we'll start by putting this over 1. We can put anything over 1. And now I need to get rid of feet. So to get rid of feet, feet are going to be on the bottom. And you think about what is a unit I know that has a relationship with feet. And I know that there's a relationship between inches and feet, right? There are 12 inches in 1 foot. So now I'm left with inches, so that's good. Okay, but I want to get to metric, and so in the notes, I gave this to you. I would have to give this to you. I don't expect you to remember it, but there is a relationship between inches and centimeters. And it is 2.54 centimeters in every 1 inch. So that would cancel my inches. And so now I'm in the metric system. That's good, but I need to get to meters because that is the standard metric unit for length. So centimeters are going to go on the bottom. And is there a relationship between centimeters and meters? Yes, there is. Okay, so let's ask ourselves, which is bigger, a meter or a centimeter? Well, a meter is bigger. So in 1 meter, how many centimeters are there? Well, centi means 100, right? 100 cents in a dollar. So there are 100 centimeters in 1 meter. Those two values are equal. So now my centimeters cancel, and I'm left with only meters. So now it's just a matter of multiplying all the numbers. So across the top, it would be 3.47 times 12 times 2.54. I get 105 point, my calculator says 7656. I won't round yet, 7656. My unit, do I have a unit on the top? Yes, I do, it's meters. So if I take that, and on the bottom, 1 times 1 times 1 times 100. So I would just take 100. Are there any units on the bottom? No, that's good. The only unit I have left is meters. So now it's just taking 105.7656 and dividing it by 100, which gives me an answer of 1.05, and I'll read you exactly what's on my calculator. 1.05766 meters. Now we want to give our answers in 3 sig figs. So 1 is a significant figure, the 0 is captive, so it is, and 5 is non-zero, so it is. So this is where I'm going to stop, but the 7 means I have to round this up. So my final answer with 3 sig figs would be 1.06 meters. So it looks like the student measured 3.47 feet, which is equal to 1.06 meters, approximately. Okay, so let's look at some scientific notation. Let's see, we've got a small number here, so we're going to move our decimal to the right. We'll count how many spots we move it as we move it. So 1, 2, 3, 4 till we get to a non-zero number. And so now, I should write that down, I moved it 4 times. We want our answers 3 sig figs, 4, 8, and 7. So those are all non-zero numbers, so they are significant. So I'll stop at 4, 8, 7. But the 6 means I need to round this up, right? So my number would be 4.88. Okay, so that's my A, times 10 to the, and now 10 to the 4th. But I move this to the right. And the rule is when I move it to the right, that means I need a negative value. So my answer, my final answer with 3 sig figs would be 4.88 times 10 to the negative 4th. This one, decimal's on the end. It's a big number, so I'm going to move it left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I moved it 9 times. Okay. I have my 1 non-zero number in front of this decimal there. So this is going to be 9.5 4 and 3 are also significant because they're non-zero, so 9.4. Let's look at this 3. The number behind it is greater than, or is 5 or greater, so this rounds up, so 9.44 times 10 to the 9th, and I moved it to the right, and so, or excuse me, I moved it to the left, which means this is a positive number. So my final answer here would be 9.44 times 10 to the 9th. So I hope this helps as you work through your practice problems.